Hello everyone. Today let's talk about some of the Git basics. Let's begin with Git local commands and its operations. This is the diagram which represents the Git local operations, where you have a local Git repository and then you have a working directory, and in middle we have a staging area. When there are changes to be made, so changes which are made at the working directory have to be added using a git add command in the staging area, and then later they can be pushed. If they can be committed into a local repository using git commit command. You cannot commit your changes directly from your local directory into the repository without going to staging area. And also you can do a multi files added into a staging area. If you want to add all the files into a directory to a staging area, you could use dot notation, which represents all the files in the current directory to be added to a staging area. And then we have git checkout is the to check out a particular branch from the local repository into the working directory. This is useful when you want to switch around multiple branches in your local machine. These are some of the git local commands: init, add, commit, log, diff. Git init is to initialize a brand new project in your local machine. Then you start working on them, doing multiple commits in the local repository. Later, that could be pushed into a remote repository. Git add is to add your changes from your working directory to a staging area. Commit is to commit your changes from your staging area into the local repository. Git log is to view all the commits in that particular local branch, which is very useful in order to look back what were the commits made on the particular branch. Git diff is to differentiate the changes between working directory and to the repository. So whenever you have working on changes, if you want to see what changes you have made in a working directory against your local repository, Git diff will show you the untracked files and also the tracked files as well. Git commit, this is the diagram which represents what is the commit is. So a commit has multiple attributes. Basically, it is the metadata about the commit, where the commit message represents what the actual message of a commit, which was given during a git commit command, and who did the commit in the author, the date on which the commit has been made, and then the actual content of that particular commit. The two important attributes here is the unique reference and the parent reference. Every commit has a unique reference ID, a SHA ID generated as part of the commit. And also it has the reference to the previous commit. So all of the commits has a reference to the previous commit except the first initial one. And if some reason, if you have a reference ID of the current commit, you would be able to trace back to the initial commit using the parent reference as an ID. So this is the representation of sequence of commits. So here we have commit 2 points to commit 1, commit 3 points to commit 2, commit 4 points to commit 3. Now, also it is possible that you could actually squash multiple commits into single commit. For example, if you see here, 1, 2, and 3 can be squashed into only one commit, and commit 4 can be directly made as point to commit 1. This is very useful in order for the reviewers to review changes. Instead of reviewing each commit, you could actually review one commit which has the changes of 3 commits as a single building block. Then we have git ref. So git ref is the pointers created in Git, where these pointers points to a particular commit. For example, all the branches have a pointers with the name as the branch name. For example, you could see a master branch here has a pointer to a recent commit and which has the same show ID of the recent commit. And also a special pointer called head, which also has the show ID, same as pointing to a current branch. So if you are check out a new branch, then head will point to a new commit. Then this is the Git remote representation where we have an additional building, additional component on top of our local representation where your remote repository comes into picture now, which has the URL representation here. And the changes from local repository can be pushed into the remote repository. Similarly, changes can be pulled back from a remote to local repository. This requires an internet connectivity. This whole section doesn't require internet connectivity, so most of the work can be done offline. And as soon as the connectivity is available, then the changes can be pushed and pulled back from the report repository. These are some of the remote commands. We have git remote, push, clone, pull, fetch, branch, checkout, and merge. So git remote is to basically add a remote reference to the local repository. It is also possible that you could have more than one remote reference added to a local repository, and in your git push and pull, you can actually refer which remote reference you wanted to pull and push the changes to and from. Git push is to push the changes. Clone is to basically clone your new remote repository to local machine. Pull is to pull the changes from remote to local machine. Fetch is to just fetch the changes but don't merge. And then later use a merge command to merge them into local repository. Git branch is to create a new branch from your current branch. And git checkout is to check out your branch into a working directory. So this is the representation of git branch where you could see that we have a sequence of commits on a branch. So we have commit M1 and M2 on a master branch. And there is a need where the sequence of work has to happen on the master branch from the commit M2. So a new branch could be created from M2, which is called a B1. And then other commits could be made on top of that, which goes B1 and B2. And then B3 can point to B2, B4 can point to B3. At the same time, the current master branch can also have additional changes where M3 and M4 have been made. M3 continues to point to M2 and M4 points to M3, etc. So, and also it's possible that you could have additional branches from same commit M2, or you could create new branches from M3 or M4. Or it's also possible to create a new branch from your B1 and B2. So, your branch is basically is again basically having a parent reference ID to a previous branch commit ID. Git checkout is just changing the reference of our head to the checking out branch. For example, if you see here, we had a sequence of commits, first, second, third, and recent commits, and master branch was pointing to a recent commit. When you create a branch from at this point of time, then say my branch, then a new reference will be created called my branch, which also points to the same recent commit. And when you do git checkout, the head reference, which was pointing to the master branch, will switch its reference to a my branch. And when you have a new commit in the my branch, a new commit will be created, which will point to the recent commit 73G56D, and the my branch will point the reference to the new commit, and the head reference also will point to the new will point to my branch, which is in turn pointing to the new commit. Git merge. So when we had a sequence of work in two different branches, you could merge them at any point of time. For example, if you have master branch had 4 commits and a branch, my branch had 2 commits, and if you decided to merge them into a single commit, we could merge them here, the way it is represented here. So merge commit is a special commit message commit which has two parent references. One points to the current branch parent, and the other points to the branch which was pulled. The chains were pulled, right? So the last reference of that commit. So here M4 and B2. So merge commit here as the two parent references. Git rebase is an interesting feature where if you don't want to do a merge and you are working on a branch which was created from the master branch, and you don't want to do a merge at this point of time, but you wanted to get the changes done in the master branch into the working branch, my branch, then we can use rebase, where the reference of B1 which is pointing to M2 will be made reference to M4. So that way you would have all the changes of your master branch into the current branch, because the current branch changes are on top of the master branch changes. That way you would get all those changes of the branch from where things were created on, as a previous changes. That's all I have at this point of time. Thanks everyone for your time.